What's up? What's up? It's your man Jimmy Chan. All right, let's get started. One. Oops. So, number one gives you that f of x is equal to x over 9x minus 7, and it wants you to find domain. Wow. Okay. It wants you to find domain. Okay? So, with that being said, what we know about fractions is that we can't have 0 in the denominator. So, for example, if I had 1 divided by 0, if you put this in your calculator, you'll get an error, which means it's undefined. Okay? So, but if you do 0 over 1, that's equal to 0. So if you ever get confused, just put in your calculator and it will tell you exactly what it is. So since the denominator of a fraction can't equal to 0, so that means the 9x minus 7 cannot equal to 0. Well, what would make it 0? So we're going to solve this the same way as if it was any regular equation. Add the 7 to both sides so that 9x cannot equal to 7. Divide by 9, so that means x cannot equal to 7 over 9. So that's the only thing that x cannot equal. It can equal anything else except for 7 over 9. So that's the reason why. Now, if it was interval notation, then we would be going from negative infinity to to 7 over 9. And then union with 7 over 9 to positive infinity. However, that's not a choice, obviously. So, in other words, we can use all real numbers, which that means, except x cannot equal to 7 over 9. So, which is choice D. And there we go. And there we go. All right, to number 2. All right, number 2. All right, so right now we're going to be dividing two fractions. So we have x squared minus 24x plus 144 all over all over 10x minus 120 divided by 2x minus 24 over 20. Okay, so the first step is going to be factor top and bottom. So I'm going to have to factor. So some of you guys who are using the AC method, you might want to put it off to the side. All right. So when you do the AC method on the top left-hand corner, that's going to be an x minus 12 and an x minus 12. The bottom is going to be a GCF of 10, leaving with x minus 12, divided by GCF 2, leaving with x minus 12, all over 20. Okay, so with division, what we have to do is copy, change, and flip. Okay, so then what we're going to do is go, okay, copy the first fraction, change that division to multiplication. And then what we're going to do now is flip the second fraction, which is 20 over 2 parentheses x minus 12. So when we multiply, what do we do? Yes, with fractions, we do top times top over bottom times bottom. Okay, so what we actually have here now is that we got 20, x minus 12, x minus 12. And the bottom is going to be also 20, because 10 times 2 is 20, times x minus 12 times x minus 12. And step 4 would be to reduce or cancel and simplify. Okay, so now what do we have here? If you notice, 20 cancels, x minus 12 cancels, and x minus 12 cancels, because 20 over 20 is just 1. X minus 12 over x minus 12 is 1. X minus 12 over x minus 12 is also 1. So therefore, the answer is 1. And that choice is D. And that choice is D. There we go. There we go. All right. So there are my steps there. All right, so on to number 3. All right, number 3 says the same thing. So what do I have? I have x squared plus 5x minus 6 over x squared plus 9x plus 18 divided by x squared minus 1 over x squared plus 7x plus 12. All right, so again, I got to factor the top and the bottoms. So what do I have? I have an x plus 6, x minus 1 over, this is going to be x plus 6 over times x plus 3 divided by x plus 1 times x minus 1, because that is the difference of two squares, over, this is going to be x plus 3 times x plus 4. All right, so now copy, change, flip. So we copy the first, change the division to multiplication, and flip the second. So we got x plus 3, x plus 4 over x plus 1 times x minus 1. There we go. Now we're going to multiply top with top, bottom with bottom. So what happens is this, right? Essentially what I get now is this. Check this out. Essentially, that's what I have now, right? So with that being said, I usually go through the top. Like, is there x plus 6 on the bottom? Yes. Is there x minus 1 on the bottom? Yes. Is there x plus 3 on the bottom? Yes. Is there x plus 4? No. So then I go, okay, so therefore I'm done now. So now what do I have left? I have a x plus 4 over a x plus 1. And that is choice C. There we go. There we go. All right. On to number 4. All right, number 4. Now we're subtracting. So I got 5 over 3x minus 7 over 5x. So what I know is that in order to add or subtract fractions, what I need is common denominators. All right, so let me duplicate that, bring that over. And what else I'm going to do is this. So what I typically tell you guys to do is break the denominator down. So this is 3 times x, and this is 5 times x. And say, what do they have that I don't have? Well, the one on the right has a 5 that I don't have on the left. And the right is missing a 3 that the left has that I don't have. Now, if we look at this denominator with this denominator, right now with the missing pieces, they both have a 3 times 5 and an x, right? So, with that being said, that means I'm going to multiply the left fraction by 5 on top and bottom, and the one on the right, I got to multiply 3 on top and bottom. So what does that give me? That's going to give me a 25 over a 15x minus a 21 over a 15x. And when I subtract, what do? I add or subtract the top and keep the bottom. So I'm going to have a 4 over a 15x. And the question is, can I reduce that? And the answer is no, I cannot reduce that. So therefore, that's going to be choice A. There we go. All right. On to number 5. All right, number 5, I'm still doing the same thing, except I have 3 over r plus 6 over r minus 9. So same thing. What do they have that I don't have? And one of the things I'm going to say to you is, if you have a binomial, put parentheses around it. And the reason why I say that is because the parentheses reminds you that r minus 9, that binomial is just a number, okay? Just like if it was 29, okay, or 23 or 52, it's a number. So I'm putting parentheses around it, okay? And it reminds me not to be able to cancel within it. So again, same thing. I'm going to go ahead and duplicate this and bring it over here. And I'm going to separate this out a little bit. So I have space here. So what do I have here? I have an r, and here I have another number called r minus 9. Well, what do they have that I don't have? Well, this one doesn't have an r minus 9, and the one on the right doesn't have an r. So again, look at these two. They both now have r and an r minus 9. Okay? So that means the one on the left, I'm going to multiply by r minus 9 on the bottom and r minus 9 on the top. And the one on the right, I want to multiply by r top and bottom. Okay, so the top I have a 3 times r minus 9 over a r times r minus 9 plus 6r over an r times r minus 9. Okay, so that's going to tell me that the top is going to be a 3r minus 27 plus 6r all over an r times r minus 9. Okay, so add or subtract the top, keep the bottom. Well, the top has like terms, right? And my like terms are what? The 3r and the 6r, which gives me 9r minus 27 over an r times r minus 9. Now your first reaction is saying, wait a minute, but there's a GCF here of a 9, which would give me r minus 3. The problem is that I can't reduce anything doing that. So therefore, I'm not even going to bother doing that, okay? So don't worry about doing that, and that is going to be my answer, which is choice D. There we go. There we go. And there's my choice D. Awesome. On to number 6. Okay. Number 6. Let's see what number 6 says. Ooh, more adding. Okay. So, the top is a m minus 6 over, the bottom is a m squared plus 10m plus 21 plus, the top is going to be a 2m minus 3 over m squared plus 9m plus 18. Okay, so again, first rule of thumb, put parentheses around those binomials, okay? I'm still going to, I guess I never gave you rules here. Let me give you the rules. 1, parentheses around all binomials, okay? Step 2, factor top and bottoms. Okay, so let's go ahead and do that. So now I have a m minus 6 over a, let me see, when I factor this, I'm going to get an m plus 3 and an m plus 7 plus a 2m minus 3 all over. This is going to be m plus 3 and a m plus 6. Okay? So step 3, get common denominators. Okay, so if I'm going to get common denominators, here we go. So I'm going to go ahead and duplicate this, bring it down, give myself some space. Okay, so what do they have that I don't have? Well, this one is missing what? An m plus 6, and this one here is missing what? An m plus 7. So again, if you look at this denominator and this denominator, do they have all 3 of those binomials? And the answer is yes, they do. So that's what I'm missing. So therefore, I'm going to go ahead and multiply top and bottom by an m plus 6. And this one, an m plus 7. Okay? So, with that being said, I can go ahead and erase this. And now my top is what? My top is m minus 6 times m plus 6. And over here I have a 2m minus 3 and an m plus 7. And both denominators are exactly the same. So, which is m plus 3, m plus 7, m plus 6. And no, those three orders don't really matter. You could put down m plus 7, m plus 3, m plus 6, m plus 6, m plus 7, m plus 3. Those three doesn't matter. Okay, when you multiply three numbers, it doesn't matter what order you multiply them in, it's all going to come out to be the same. Now, here is going to be where the tricky part is. Now, I just got done factoring, right, to break these down so I can get a common denominator. Now, I'm seeing multiplying two binomials, so that means I got to double distribute or FOIL again. Oh boy, and combine the top, so I can combine the top, all right? So, the m minus 6, m plus 6 is a conjugate, and we need to recognize that. So, I don't need to FOIL that. All I have to do is FLA that, right? So, this is going to be a m squared minus 36. Plus, this one I do have to FOIL, which is 2m squared plus 14m minus 3m minus 21 all over m plus 3, m plus 7, m plus 6. All right, so let's look at like terms here. So I got m squared, I have m, and I have negative 36 and negative 21. Okay, so what is that going to equal to? That's going to give me a 3m squared plus an 11m minus a 57. Is that what it looks like? Okay, all over m plus 3, m plus 7, m plus 6. So no, I never want to double distribute the bottom. I want to keep it as is. And the only reason why I actually FOILed double distribute the top is to combine them. And I get a brand new trinomial here. Okay? So the thing I do have to do, however, is to look at this trinomial and saying, okay, so the a times c, I got to try to factor this to see if anything on the bottom would cancel. So a times c is equal to 5 times a negative 57. So let me see what that is. It's 3 times a negative 57 is going to give me a negative 171, and my b is equal to 11. So I go, okay, negative 171. Let's see here. If I multiply these two numbers, that has to be one's positive, one's negative. To get a positive 11 means the bigger number has to be positive. So negative 1, positive 171. Okay, what's 171 divided by 3? Oh, negative 3 and 57. It can't go into 2. It can go into 3. Does it go into 4? Nope. Can't go into 5. Can't go into 6. How about 7? Nope. How about 8? I'm going to say no. 9, no. Oh, 9 it does. Okay, so negative 9 and 19. All right. Well, if you notice that none of these can go into, that will kind of add up to give you positive 11, right? It gave me a positive 10, but not a positive 11. It gave me a positive 54, but not a positive 11, all right? So therefore, I'm stuck, all right? So let me see here. I'm trying to see if there's anything else that goes into it. Definitely not 15, not 16, not 17, not 18, so nothing. All right, so that was all it is. So since when I add these, I get 171, 54, and 10, and I can't, and none of these equal to 11. Right? So that means this trinomial is not factorable. So therefore, I'm taking this and taking it away. So this right here is my answer, and that is choice C. Here we go. And there we go. All right. So that's number 6. So on to number 7. All right, number 7. Ooh. These ones here are called complex fractions. So this is 3 over x plus 5. Notice I'm going to put parentheses around those as well. Plus 9 over an x plus 3. All over 2x plus 9 over a x squared plus 8x plus 15. Okay, so these are called complex fractions. Okay, they're called complex fractions. So number 1, get top to be 1 fraction. 2, get bottom to be 1 fraction, right? And then 3, copy, change, flip. And then 4, simplify. Okay? So, when I say get top to be 1 fraction, what we're going to do is just focus on just the top. Okay? So we're going to forget about the bottom. So we're going to ignore this right now. Okay? And we'll only focus on just the very top here. Okay? So with that being said, I asked myself, what does one have that the other one doesn't have, right? So let's go ahead and do this really quick. I'm going to go ahead and take this out, duplicate this and bring it down. Okay. And give this a little bit of space here. There we go. So what the left denominator doesn't have that the right denominator has is an x plus 3. So we got to multiply it to the top and bottom. The one on the right doesn't have an x plus 5 that the left has. All right. So with that being said, now if we look at the denominators, they are the same. So what do I have now? On top, I have a 3x plus 9 plus a 9x plus 45 all over x plus 5, x plus 3. So that's going to equal to a 12x plus 54 all over x plus 5, x plus 3. Okay, so the top is done. Now, the second step is to get the bottom to be 1 fraction. Good news is the bottom is already 1 fraction. Okay, the only issue is that the bottom needs to be factored. So if I factor the bottom, so let me do it this way here, just so that you guys can kind of follow a little bit. Do it this way. Duplicate that so the bottom still stays the same. All right. There we go. All right. So now I can still do all right. So now what I have here is this. So this is going to be now over 2x plus 9 all over, and when I factor this, it's going to be x plus 5 times x plus 3. Wow. All right. So what do I mean by copy, change, flip? Well, this right here, guys. Oh, actually, I can just do this. This right here just means that it is dividing. That's all that means. So essentially, I'm taking one fraction and divided by a second fraction. Okay? So when I say copy, change, flip, that's exactly what I mean. So I'm copying the top. Changing division to multiplication, and flipping the bottom. And I should have parentheses around these binomials. Okay. So, again, what do I have? Again, I have essentially this. Okay, so I go through the top, that goes away, that goes away. I'm left with 12x plus 54 over 2x plus 9. And you look at that answer, you look at the answers, and that choice isn't there. You're like, wait a minute, what's going on? Well, here's what's happening. There's a GCF on top, and the GCF is 6. So the top actually has a GCF of 6, leaving you with a 2x plus 9. Ooh, seen that before. Look at that. So those can cancel out. So I would be left with just a plain old 6, which is choice number B. There we go. All right. Now on to number 8. All right, 8 says 49u squared minus 25t squared all over tu all over 7 over t minus 5 over u. Okay, so notice the top, again, is a single fraction. Great. Don't need to do anything with that right now. I can factor it, but that's about it. But if I focus on the bottom, okay? If I focus on the bottom, what does the right fraction have in the denominator that I don't have in the denominator? And that would be a u. What does the right fraction not have in the denominator that the left has in the denominator? That would be t. Awesome. So let's go ahead and use my nifty thing here and duplicate this and bring this over and just say that this is equal to that. Awesome. So the bottom is now going to be a 7u minus a 5t all over a tu, right? Awesome. Now I got both of them a single fraction, but the problem is the top I can also factor, because look at what this is. That is the difference of two perfect squares, because 49 is a perfect square, 7 times 7. U squared is a perfect square, u times u. 25 is a perfect square, 5 times 5. T squared is a perfect square, t times t. And it's subtraction. So that means the top is going to be a 7u minus 5t times 7u plus a 5t all over tu, and that's going to be all over 7u minus 5t all over tu. So now copy, change, flip. All right, so I need to copy this. Done. Change that division bar to multiplication and flip the bottom fraction. So tu over 7u minus 5t. Awesome. Okay, so like I said to you before, this is essentially equal to, because it's top times top, bottom times bottom. So let me bring that over here now and erase this multiplication and just bring this right here over and connect. There we go. So if you look at it, 7u minus 5t, yep. 7u plus 5t, no. T, yes. U, yes. Awesome. So what do I have left? I have left just a 7u plus 5t. So that would be my answer, and that is choice A. There it is. And that is choice A. Just confirming with the piece of paper that I already did the lab work on the first go around, and now there's the second go around. All right, so there's 8. Let's look at number 9. All right, number 9, bringing back some memories. So I got negative 5x to the negative 1 plus 6y to the negative 1 all over negative 4x to the negative 2 minus 5y to the negative 2. All right. So this is where you guys get certain things confused. All right. So let me clarify things for you. So if I look at just, how do I do this? If I just look at just this right here, the negative 5x to the negative 1, what does that really mean? So let's go ahead and take this right here and bring it right over here. If I had negative 5x and negative 1, what does that really mean? So the first question I'm going to ask you is, this power negative 1, what is it attached to? And you're going to say, well, it's attached to the x and the x only, because there's no parentheses. And I said, yep, you're absolutely right. So that's going to give me a negative 5, because the x doesn't like being on top. The x goes to the bottom to be the first power, but we won't write the first power because that's already understood. So negative 5x and negative 1 would be negative 5 over x. Okay? So remember how I said to combine the top, right? Remember that this right here is the top of the fraction. So I have to isolate this just by itself and nothing else. I got to ignore that bottom. Okay? So with that being said, let's go ahead and do everything else the right way here. So let's delete that. So now I can say that this is equal to negative 5 over x plus 6 over y, because it's only attached to the y. And the bottom is going to be a negative 4 over x squared minus 5 over y squared. Again, back to the complex fractions. All right. So I got to combine the top. I got to combine the bottom. All right. So if I combine the top, I ask myself, what does one denominator have that the other denominator doesn't have, right? So the x is missing a y. The y is missing an x. Awesome. Now let's look at the bottom fraction. Well, the x squared is missing a y squared, and the y squared is missing an x squared. Okay. With that being said, now let's see what that looks like. Well, that's going to be a negative 5y plus 6x all over xy all over negative 4y squared minus 5x squared over x squared y squared. Okay, so this is where we copy, change, flip, right? All right, so this is now going to equal to copy negative 5y plus 6x over xy, change division to multiplication, and flip the bottom fraction. X squared y squared over negative 4y squared minus 5x squared. Awesome. So these are binomials, right? So let's put parentheses together. This one right here is the difference, but not of two perfect squares, right? Negative 4 is not a perfect square. Y squared is, but 5 isn't. So since there's a bunch of no's in there, we just say, okay, this is not the difference of two perfect squares. So we're good with that. So now, what is this going to be when we multiply top with top, bottom with bottom? It's going to be this right here. That goes away because it's top times top. So go boop right there. Right there. All right. So we go through it. Okay. Is there a negative 5y plus 6x on the bottom? No. Is there x squared on the bottom? Not x squared, but there is an x on the bottom. So the x cancels out, leaving me with x on top. The y cancels out, leaving me an actual y on top. So my answer is now x times y times this parentheses negative 5y plus 6x over just a negative 4y squared minus 5x squared. Oh, awesome. All right. So when you look for this answer, not quite on there. Okay. However, what is there is if we decided to distribute this xy. So if I distribute this xy in here, what do I get? I get a negative 5xy squared plus 6x squared y all over negative 4y squared minus 5x squared. Okay. Now, the reason why I tell you guys to put parentheses around the binomials is because I don't want you to get to the point where you're going to cancel these x squares out and these y squares out and these negative 5s away and so on and so forth, right? Because that is something we cannot do. Okay. Doing that is actually very wrong, morally speaking. And what do you mean by morally? If you think about a number, right? Or think of the parentheses as like a house. It's not right for you to go into someone else's house and taking someone out of there, okay? That you can get arrested for, and it's morally wrong. The other thing is that if you think about this, let's say the top number is 38 and the bottom number is 23. Well, I can't just say, well, 3 cancels out, so this is 8 halves, and then so this is equal to 4. Well, 38 divided by 23 is not 4, right? That is not the case. So that's the reason why we can't do that, because the parentheses on top is just a number like 38. The parentheses on the bottom is just a number like 23. We just don't know what the value of the x's and the y's are, and that's the reason why we can't just pick what we want to cancel out. So this should be your answer, and you should have a answer of exactly this. Ooh, excuse me. Let me slide this over just a little bit just so I can put that letter there, and that is going to be choice B. All right. There we go. And there we go. All right. I didn't realize that the B was going to be that close. There we go. All right. And off to number 10. Do we have enough space for 10? Yes, we do. So number 10. All right, number 10. Oh, another one like that. Kind of. Okay, so I have 7x to the negative 1 plus 2y to the negative 1 all over x to the negative 2. Okay. So again, we convert all of these negative exponents. So I'm going to have a 7 over x plus, now look at this power, right? The negative 1 is actually connected to the parentheses. So the parentheses is being affected by that negative 1. So it's going to be 1 over 2y, and that whole thing is over 1 over x squared. The nice part for you guys, the bottom is already a single fraction. So I gotta get the top to be a single fraction. So how do I do that? Well, what's the x missing? Was missing a 2y. What is the 2y missing? It's missing an x. Awesome. So now, what is my top going to equal to? My top is going to be a 14y plus x all over 2xy. And that is over 1 over x squared. So let's copy, change, flip. So 14y plus x all over 2xy. Change division and multiplication. Flip the bottom. Awesome. Don't forget the parentheses because it's a binomial. So all I have is, I don't have a 14y plus x on the bottom, but I do have an x on the bottom that will cancel out with that x squared, leave me with an x left. So my top is going to be an x times a 14y plus x, and my bottom is going to be left with just a 2y, which that result is not as a choice. However, if you distribute the x through the top, get 14xy plus x squared all over 2y. And that, ladies and gentlemen, is a choice. And that choice is C. Awesome. There we go. All right. Well, I hope all of this input helps. If there's any questions, please let me know. See ya.